Hello, now we're going to continue our work with our factors that we've already started with our highest common factor, and this time we're going to look at lowest common multiple. And just like highest common factor, lowest common multiple tells us what it is in its name. Lowest means smallest, common means it's going to be connected to two numbers, it's going to be common to two things, and multiple means we're dealing with multiples of numbers. So if we look at our definition, the smallest multiple that two numbers share. The smallest multiple that two numbers share. So I know what the word smallest means, and I know what two numbers mean, and I know that they're going to share them. But I want to remind myself, what does multiple mean? Well, the multiples are our times tables. So if we take an example like 5, what would be the multiples of 5? Well, it's our times table. So our first multiple of 5 is actually 5, because 5 by 1 is 5. What's our next one? 5 by 2 is 10. That's 5 multiplied by 2 is 10. Our next one is 5 by 3 is 15. And we can keep going on up. So multiples are just our times tables. That's all they are. So our first multiple of 5 is 5, because when we were doing our times tables, we started off with 5 by 1 is 5. And it's the same multiples. 5 is going to be our first multiple of 5. Now, that's the idea of multiples. So from there, we can keep going. Now we're going to be looking for the smallest multiple that two numbers share. So let's pick two numbers and find the lowest common multiple. And in this case, let's try 3 and 7. We'll try bigger numbers in a minute. So the easiest way to do this, if we have really small numbers, is just like what we did for the last several years. If we wanted to know multiples of a number, we're just going to write out their multiples. We're going to write out our times tables. So the multiples of 3 by 1 is 3, 3 by 2 is 6, 3 by 3 is 9, 3 by 4 is 12, 3 by 5 is 15, 3 by 6 is 18, 3 by 7 is 21, 3 by 8 is 24. But I catch myself. I remember from my times tables that 21 was one of the multiples of 7. So I'm going to stop now. I know that that pattern keeps going, and I can keep going with it if I'm wrong. But I remember 21. So I'm going to see if I write out my list for the multiples of 7, is 21 going to be on my list? So the first multiple of 7 is 7, because 7 by 1 is 7. 7 by 2 is 14. 7 by 3 is 21. And just for completeness, 7 by 4 would be 28, so we can see the pattern continuing. And now I see 21 is the first number that is in both lists. What does that mean? It's the smallest multiple that two numbers share. The smallest multiple that two numbers share. So that means that the lowest common multiple of 3 and 7 is going to be 21. It's the smallest multiple that both of those numbers share. Now there's a connected idea there, because we know that division and multiplication, we've mentioned it before, are going to be opposites of each other, or in math speak, inverses of each other. There's another way of looking at that, in that 21 is the smallest number that 3 and 7 are factors of. That's the other way of looking at lowest common multiple, and it's important to have that in our back pocket, in the back of our minds as we're going forward, that the lowest common multiple is also the smallest number that our two original numbers, our 3 and our 7, are factors of. So 3 and 7 are factors of 21, and that's the smallest number that both 3 and 7 are factors of. So let's go on and look at an example where the numbers are bigger, and writing out a list of the multiples would start to get very irritating. So that's what we want to do now. Now let's have a look at the lowest common multiple of 28 and 6. So 6 wouldn't be too bad for doing times tables with, but 28 I would find very difficult to do times tables for. So what we're going to do is a slightly different method. We're going to find out the prime factors of both of these numbers, and the reason why we'll be able to see by the end. But for right now, I just want you to trust me. We're going to try and get the prime factors of both numbers. So let's start with 28. So 28, the smallest prime number that's going to divide into 28 is going to be 2, and we're left with 14. And the smallest number to divide in will be 2, and we're left with 7. And then the smallest prime number to divide in will be 7, and we're left with 1. And the job is done. So we have 2, 2, and 7 are the prime factors of 28. Now what are the prime factors of 6? Smallest number or prime number that divides into 6 is 2, and we're left with 3. Smallest prime number that divides into 3 is 3, and we're left with 1. So 2 and 3 are the prime factors of 6. Now, what we are going to do is try and create the smallest number that has all of these factors included, but only the ones that we need. Now, what do I mean by that? If we just multiply up all of these factors, all of these prime factors together, we'll get a number that's bigger than we need, and we want the smallest, the lowest common multiple. So what are we going to do? We're going to take and form a new list. And I'm going to write it out, and I'm going to show you how it is we come to it. So we're going to want 2, 2, 7, and 3. Those are the prime factors of the number we're looking for. Now, why have I done that? Because I want my lowest common multiple to have all of the factors of my two original numbers. If it has all of the factors of my two original numbers, that means that my two original numbers will be able to divide into it. They will be factors of my new number. Remember, I mentioned that that's another way of looking at my lowest common multiple. So let's see if we have that criteria met. I need to have a 2, a 2, and a 7 for my prime factors of 28. So I have a 2, a 2, and a 7 for my prime factors of 28. And I need to have a 2 and a 3 in order to have the factors of 6. So I have a 2 and a 3 are my prime factors of 6. So I can see that this number, when I multiply all of these 4 numbers together, I'm going to get a number that contains all of the prime factors of both of my original numbers. So when I do that, I'm going to have 2 by 2 by 7 by 3. Lots of multiplying to do. So we're going to start off at the left-hand side, and we're going to have 2 by 2 is 4, and we're left with 7 by 3, and we have 4 by 7 is 28. So we're still working over here, 28. These numbers are getting quite big, but hopefully you will be comfortable that we can have 28 by 3 is going to give us 84. So we multiply that together and we get 84. So 84 is the lowest common multiple of 28 and 6. Now, we should be able to double check that. I claimed that we were doing this because if we had a number that had all of the prime factors of our original numbers contained within it, then we should be able to divide both numbers in. So let's try that out. So 28 and 6 should be factors of 84, which means they should divide in. So 84 divided by 28 gives us 3. And 84 divided by 6 gives us 14. So 6 and 28 are both factors of 84, which is a pretty good indication that we got our method correct. So we need both of these methods in order to be able to solve problems. We need to know our times tables, and we can write out our lists and see what the smallest number that's common to both lists is. And we also need to be able to do our finding our prime factors and then creating a number that has all of the factors of both of the numbers without extra repetition. So there isn't 3 2s here, even though there's 3 2s in my original list, because I only need 2 2s and 1 2 for my numbers to work out. So that is our idea with lowest common multiple, and we need to be able to follow both methods.